the last video of part B, B.5, explanation of quiz 1 questions, part 3. We have last 4 questions for this quiz. First one, question 7. When we apply the linear search on a given array, which of the following types of arrays do we expect to work on? Expect to work on. Now, we know linear search is used on unordered arrays. Unordered arrays. All right, in general, the general case. Yeah. But if we happen to get an ordered array, right, we can still apply linear search. All right, yeah. So here, I think most of you probably, I think, will choose the correct answer on an unordered array. Yeah. But it is possible, small number of students, you may pick the ordered array. Yeah. Although it is wrong. Yeah. But here, I may like to point something out. Yeah. So for the general situation, we expect to get an unordered array, right? Yeah. So that's the, usual situation. But when a given array happen to be ordered array, do you know it is an ordered array? You don't know, because you do not have time to check it. You have no chance to check it. Although you can check it, you can, try to go through the array and see if it is an ordered, but it is, you need to pay the cost. You need to pay the cost. And we don't want to pay the cost. We don't want to pay the checking cost, right? But nobody wants to pay the checking cost. Now, for that reason, even if an ordered array is given, we apply the linear search on it. Okay? Yeah. Yeah. Some of the students may feel, we can check if it is ordered. If it is ordered, then we can apply binary search, right? Binary search will be much faster than the linear search. Yeah. We will learn the binary search in our module 4. Module 4, divide and conquer. So then we will learn the binary search. Yeah. All right. Yeah. But here, yeah, this one may connect to the binary search a little bit. Yeah. But, whatever reason, the answer is B. Yeah, the second one, unordered array. Yeah. All right. Next question, number 8. Given a computing problem, if you have an algorithm to solve it, and you cannot improve it anymore, here, all right, here, I put a U, right? Yeah. The U here means the problem solver, okay? Some problem solver, yeah. General problem solver. So if you cannot improve it anymore, then you can say that your algorithm is optimal. Now, this question, we want to check your understanding of this concept, optimality concept. Answer is false. The answer is false. All right? Yeah. The explanation very simple. You cannot improve it anymore. Is it possible that someone else can improve it? Furthermore, right? Yeah. So other people can improve. How do you know other people cannot improve it? Right? You have to prove it. If you want to say it is optimal, you have to prove it. Remember, in our optimality topic, in the finding the minimum example, we did a proof. We made convincing arguments. Think about that, convincing arguments. So here, you need to make your convincing arguments. If you want to say it is optimal, You need to make your own convincing arguments. All right? Yeah. So that's the point. Okay? Yeah. All right. Next, question number 9. We have an optimal algorithm that solves the finding the minimum problem for a given array. Yes, here. This is a simple fact. This is a simple fact. I mean, just check if you're familiar with the material. Yeah. I mean, this question is too easy for you. Yeah. Too easy for you. Yeah. Yeah. Sometimes I may give some very easy questions, yeah. Try to make sure you have some easy points. Yeah. Yeah. It may not be a good way. So if I give all the questions very challenging, that means too much work for you, right? Yeah. So sometimes I want to make the whole assignment not too much harder than necessary. Yeah. So I may give some pretty easy questions. This is the one, right? And this is the one, If you're familiar with the material, or if you just, study that topic, finding the minimum. So we spend a lot of time. If you, have some impression on it, then you can answer the question easily, like this one. All right? Yeah. Next, our last question of this quiz. Yeah. This one, I may have some, comments. All right. Given an array with 100 elements. All right, yeah. So it's a linear search problem. N equals 100. The array size, it is known that the probability of a key to be appeared in this array 0.8. That probability is given, right? So that's the P equals 0.8, right? What is the average number of comparisons to get the search result? Okay. This question, if you know the formula, you just plug in the numbers, you can get the answer, right? If you just plug in the number, all right? Yeah. So here, let me get the formula, two related formulas here. Which one you should pick? Which one you should pick? All right, yeah. So look at the first one, weighted average. Second one, dominant term. Two things, yeah, slightly different. Yeah. First one, weighted average. Is this weighted average corresponds to the one in the question? The average number? Yeah, that's weighted average. Yeah. But the second one, the dominant term. Yeah. Because I notice some students may use the dominant term formula. Yeah. But here I do not mention the dominant term, right? Yes, I do not mention the dominant term. All right. So you need to think about the small difference. There is small difference there. All right. Yeah. Yeah. Because for some students, yeah, here I try to just understand the psychology of when you work on this question. What is the psychology you use in your thinking? Yeah. You may have some, special psychology based reasoning, right? Here, we know this formula looks relatively complicated, right? Comparing with this one, much more complicated. Yeah. People tend to use simple formula. Yeah. Yeah. So they feel these two essentially the same, right? Very close, essentially the same. Yeah. Then the second one much simpler, so why not just use the simpler version, right? So that could be some possible psychology. Yeah. First one is the correct formula. Second one, we can call it approximate formula, not exact formula. The first one is exact formula. The second one is approximate. Formula. Right? Here, you can see the difference. Yes. Yeah. All right. So let us use the first one first. Okay. All right. Yeah. Plug in numbers. You need to do a little work. 1/2 times 101, right? Yeah. Times 0.8 plus 100 times 0.2, right? Yeah. Equals 0.4, all right? 0.4, 40.4, right? Plus 20, okay? Yeah. All right. Another, so you get 60.4. All right. Yeah, I hope my computation is not wrong. All right, let me double check. Yeah, 0.4, 404 point. So 40.4, 20, yeah, 60.4. All right. By first formula, we get 60.4. By the second one, very easy, right? So 1 minus 1/2 point times 0.8, 0.4, right? Yeah. Then times 100, yeah. So you get 60. All right. These two numbers, yeah. Because some students told me they put this 60 numbers. Then after they checked the answer, they lost all 4 points. Yeah. Here, let me explain, this situation. Yeah. So when you put this answer, you lost all the 4 points. Yeah. I feel you deserve partial credit. All right. You deserve partial credit. Yeah. So if you got this one, you can get 4 out of 4. 2 out of 4. You can get 2 points back. You can get 2 points back. Yeah. Because you just did partially wrong, not completely wrong. All right. Yeah. But the problem is the quiz grading system. Look at the Canvas here. Let me talk about Canvas quiz grading system. All right. This quiz is graded by that system automatically. Not by me. Not by me. If I do the grading, so I will be very happy to give you 2 points. Yeah. All right. But the grading system is not that smart, right? The grading system just uses my correct answer. I enter correct answers to all the questions. They just compare your answers with my answers. If it is not completely matched, then you will lose all the points. That's what the system doing here. Right? Yeah, I know it is not smart. It is not smart, but that's the best the system can do. All right. Okay. So if you have the situation, so things like this, all right, yeah. Because I cannot see your answer. Yeah. I can only see your final grade. I cannot see your answer. Okay. Yeah. If you get a 60, you can take a screenshot. Can you use a screenshot software snipping tool? So in Windows, there is a snipping tool, snipping tools, right? Yeah. Mac, you have something called Grab or something. Yeah. Yeah. You just find some simple screenshot software. You cut that screenshot, this question, 60, send the image to me, then I will manually give you 2 points back. I can change your grade. Yeah. I just manually give you, 2 points back. Yeah. No. Another thing, another situation, one student told me, because sometimes after you get a correct answer, you just put that one number. You do not put, any words, everything, because it's not graded by human. It's graded by machine. For example, we have a question, polynomial, 10 terms, right? Polynomial with 10 terms. The answer is 9, right? Then some student after they put 9, they type some explanation, just a few more words, then they lost all the points. 9 is correct, but so they put some comments. Then the system is not that smart, right? So the system cannot, just compare the 9, ignore the remaining part. It cannot, right? So you lose all the points. In that situation, if you have the similar situation, right? Your answer is correct, but you put extra, something extra. You lose all the points. In that situation, also you take screenshots. Send image to me. After I see it, I will give you all the points back manually, right? Manually, all the back. I can do that. Okay, I do correction one by one. So whenever I see one correction, so then I will do that. All right? Yeah. So here, that's this question. But there is another point I want to point out. Yeah. Some students, there is another possibility. Some students, when they see, they use the correct formula. They use the first formula. That's correct. But after they get 60.4, they see, here we are talking about number of comparisons. They feel the number of comparisons should be an integer. Yeah, some students have that kind of impression. Because by the common sense, number of comparisons should be integer, right? You cannot do half comparison, right? Yeah. All right. So then they drop the, 0.4. They enter 60. There is a possibility some students may do in that way. Here, I want to point out the problem. Here, why we take 6.4, not 60? Because when you look at the average, when we do average on integer numbers, we can get fractional numbers. We can get numbers with fractional part. That's normal. When you talk about average, we don't have any problem to have a number point something. That's okay, because after the average, you will get fractional part. And we just take it. We just take it. All right? Yes. Yeah. Do not drop it automatically. Do not drop it automatically. All right? But that's the average. Okay? But for the best case, worst case, then we should not have the fractional part, right? The best average, the worst average, worst case, not average. The best case efficiency, the worst case efficiency, then we expect to have integer. But when we talk about average, we always allow to have fractional part. Yeah, so that's another thing, problem that you may have. All right, so let me finish part B right here. Yeah.